Salam, peace be upon you. This is part 57, and part 57 introduces what we call the closed meta loop. That name might sound technical, so let me bring it down to everyday life first. Because if you can feel it in everyday life, you will never forget it. The simple story: why good tools become blind tools. Imagine you live in a village where everyone draws water from one well. For years, the water tastes fine. People build their whole life around it. Then slowly, the water changes. Some people get sick. But the village has a tradition. This well has always been good. The well is trusted. So when the sickness comes, they don't question the well. They question the people. They say, "You are weak." They say, "It is your stomach." They say, "God is testing you." They keep using the same well because the well is tradition. Now imagine another village. They also have a well, but they have a rule. No tool is sacred. If the well is our only source, then testing the well is part of life. So when people get sick, they ask, have we tested the water? Have we checked the depth? Have we checked the filtration stones? Have we measured what we can measure? And then they don't stop there. They improve the well. They deepen it, filter it, redirect runoff, build a better bucket, cover it so animals can't contaminate it. That second village has something the first village lacks: a self-correcting loop. Science, in Holophase, is not a statue. It is not a monument carved in stone. Science is supposed to be like that second village, a living immune system. It must detect its own weaknesses, correct them, and become stronger. That is exactly what the closed meta loop means. It is the firewall mechanism that ensures the entire process of science is self-correcting and self-improving. The core revelation: science must loop back onto itself. Here is the core revelation of part 57, said in one breath. 5 sentences lead to candidate grammars. Grammars face firewall tests. The tests produce diagnostics about our blind spots. Those diagnostics force upgrades to our instruments and our windowing methods. Those upgrades produce better phi sentences. Better phi sentences refine the grammars, and the cycle repeats. In other words, science becomes an engine that upgrades its own eyes. And the skill you gain in this part is this: you learn to see science as a feedback system, not a statue. You learn to evaluate a scientific enterprise not by its current claims, but by the health, speed, and honesty of its self-correction loop. Because a field can produce 1,000 papers and still be stuck. A field can be loud and still be blind. A field can be fashionable and still be decaying. The closed meta loop is what prevents that decay. The core question: does our method improve itself? The core question here is about vitality. Does our knowledge-making process improve itself? This question targets a dangerous failure mode called methodological stagnation. Methodological stagnation is when a scientific community's tools and procedures freeze. The community keeps publishing, keeps talking, keeps producing results, but the underlying method for validating those results is no longer questioned or improved. The machinery of truth has rusted shut, even while the factory keeps running. It becomes like a man using an old, cracked mirror to shave every morning. He keeps shaving, he keeps thinking he looks fine, but the mirror is warped, and he does not realize how distorted his own face has become in that reflection. The closed meta loop is the engineered solution. It takes everything the firewall has built: licensing phi windows, proposing grammars, testing them with falsification and variation and independence and scope discipline, archiving their failures, and then it folds that whole process back onto itself. It asks, can we use the grammars we have licensed to build better instruments? And then, can we use those better instruments to gather cleaner phi sentences to test and refine the grammars that helped build them? If yes, the loop is alive. If no, the field is dying, even if it looks busy. The key idea: rules must also improve the process of rule making. Now listen carefully because this is subtle and powerful. In Holophase, a rule about nature is not true just because it fits today's data. It is also judged by whether it helps the method improve. A candidate grammar must earn its license not only by surviving tests, but by contributing to better seeing. Because if your grammar is true, but it blocks better measurement, or it discourages deeper testing, or it makes you comfortable with ignorance, then it is not serving reality. It is serving comfort. So the loop demands that methodological rules, rules about how we do science, must also earn their license. They must be tested and improved. That is the deeper meaning of the closed meta loop. The discipline itself becomes subject to discipline. 5. The loop told as a simple cycle. Let me now tell you the loop as a simple cycle, like a story of planting and harvest. Step 1. We begin with 5 sentences. 5 sentences are our licensed observations, the things we can actually measure about phi within a stable window. A sentence is not a guess. It is a recorded moment of reality, a measured pattern captured with context. We can call the set of 5 sentences S. For audio, think sentence set S. This is our raw crop. Step 2. From sentence set S, we propose a candidate grammar. A grammar is a rule, a constraint, that tries to explain the patterns in S. It tries to say, these sentences are not random. They follow a lawful structure. We call the candidate grammar G. For audio, grammar G. Step 3. We test grammar G against sentence set S. Testing is not just does it fit. Testing is firewall testing. Falsification attempts, variation tests, independence checks, scope discipline. We push the grammar. We try to break it. We measure where it fails. We can call this testing phase T of G and S. For audio, testing T applied to grammar G and sentence set S. Step 4. Testing produces diagnostics. Here is the crucial part. The output of testing is not only pass or fail. The output is also a set of diagnostics, clues about where our observation process was weak. Maybe our omega measurements were fuzzy because our clocks jittered. Maybe our kappa resolution was too coarse, blurring spatial structure. Maybe our new inference was noisy because our sensors coupled poorly to the phi field. Maybe our windowing protocol was badly designed and we licensed unstable domains. These diagnostics often come from the shadow archive, the anomalies and counterexamples we logged. Those anomalies are not just problems, they are messages. They tell us, your vision is weak here. Step 5. We use diagnostics to upgrade instruments and windows. We build new clocks with less jitter, omega upgrade. We build new sensors with finer spatial resolution, kappa upgrade. We decouple our apparatus from environmental noise so we can track propagation more cleanly, new upgrade. We also refine our licensing protocols, the filters and criteria we use to declare a window stable. This upgraded apparatus we call I prime. For audio, instrument suite I prime. Step 6. We deploy instrument suite I prime and collect new sentences. Now we get a new sentence set. Because we see more clearly, the new sentence set is cleaner, higher resolution, less noisy. We call it S prime. For audio, sentence set S prime. Step 7. We refine the grammar and test again. We take the old grammar and refine it, or propose a better grammar informed by the new data. Call it G prime. For audio, grammar G prime. Then we test again, testing T applied to grammar G prime and sentence set S prime. And then the cycle continues. This is the closed meta loop. In simple story form, better seeing gives better data. Better data gives better rules. Better rules expose weaknesses in seeing. Weaknesses drive better seeing. That is the loop. 6. Why triunity matters. The loop must improve omega, kappa, and nu together. Now we bring in the holophase discipline that prevents a subtle trap, lopsided progress. The triunity is non-negotiable. Every iteration must improve omega, kappa, and nu together. Because if you improve only one, you might get the illusion of progress while actually becoming blind in another way. Let's tell this with a vivid example. Imagine you build a fantastically precise clock. Your omega resolution becomes sharp like a razor. You can measure tiny timing differences. But to build this clock, you create a massive machine that vibrates and radiates noise and heat. Now your kappa resolution collapses. The spatial structures you are studying get smeared. Your new inference collapses because the machine itself disrupts the very propagation you are trying to observe. You improved omega, but destroyed kappa and nu. That is not progress. That is a trade of blindness. A healthy meta loop demands balanced improvement. Omega improvement means reduced timing uncertainty. Your ability to resolve rhythms and durations gets sharper. Kappa improvement means reduced spatial uncertainty. You can see finer structures, sharper boundaries, more detailed correlation geometry. Nu improvement means reduced propagation uncertainty. You can track motion and coupling more cleanly and predictably. A healthy loop tightens all three together. You can think of it as tightening a knot in three directions at once. If you pull one string and loosen the other two, you do not tighten the knot, you deform it. So the loop's health is measured by joint tightening. In the original text, this is described as shrinking the product of the three uncertainties, delta omega times delta kappa times delta nu. In audio-friendly language, the combined blur across time, space, and motion must shrink together. 7. Energy as tally. Why better instruments stabilize conservation. Now we connect to an important holophase principle. Energy is tally. In the meta loop, energy tallies become more stable and reliable, not because we believe in conservation harder, but because measurement becomes better. Many apparent violations come from leakage. We miss part of the coupling because our sensors are too coarse or our window boundaries are too small. When instruments improve, leakage decreases. With better kappa boundaries, we include all relevant correlated structures in the accounting. With better omega tracking, we catch fast exchange events we previously missed. With better nu inference, we track flow and coupling more cleanly. Then the tally converges. The accounting becomes consistent because the accountant finally has a better ledger. This is a beautiful inversion. Conservation is not a faith. It is a limit of improved measurement and correct boundary definition. A concrete historical story. Microscopes and the birth of cell biology. Now let me anchor this in a story from real scientific history, because the listener must see that this loop is not fantasy. It is what made science work when it worked. Think of early microscopes. Early microscopes were like blurry eyes. They showed that tissue was not uniform, but granular. These were 5 sentences. Blurry but real observations. From those observations came a candidate grammar, cell theory, grammar G. The claim, living tissue is made of cells. Then testing revealed anomalies. Inside the cells, details were unclear. Structures were hinted but not resolved. The grammar was good, but the sentences were too coarse. That diagnostic drove instrument upgrade. Better lenses, better staining methods, better control of light. That is I prime. Those upgraded instruments produce new sentences. S prime. Clear images of membranes, nuclei, and internal organelles. With these sentences, the grammar was refined into a deeper grammar, molecular biology, grammar G prime, and the loop continued. New instruments revealed deeper structure. Deeper structure demanded new grammars. New grammars demanded better instruments. This is the closed meta loop in action. 9. The firewall role. The loop auditor. Now we define the firewall's role here. The firewall becomes the loop auditor. At certification gates and during periodic reviews of a field, the firewall asks one specific question. Show us the loop. Meaning, show us that this rule is alive inside an iterative process. A rule is never final. It must remain exposed to upgraded instruments, new windows, new regimes. And that exposure must be recorded in the rule's lineage. So the rule's registry entry must contain version history, how the grammar changed when new data arrived. The firewall auditor checks three things. First, loop activity. Is there evidence of recent iteration? Has the rule been tested against data from improved instruments? Or is it living on old measurements while pretending to be final? Second, balanced improvement. Did upgrades sharpen omega, kappa, and nu together? Or was progress lopsided, creating new blind spots? Third, diagnostic honesty. Were upgrades driven by genuine anomalies and diagnostics from the shadow archive? Or are they random technological leaps that do not actually address the weaknesses? The firewall can mandate loop iteration. It can say, your rule has been stable for a decade, but instruments improved fivefold in your domain. You must retest your rule using the new instrument suite and report the new sentence set and any refinements. Your certification depends on loop activity. This is how the firewall prevents a field from living on nostalgia. 10. The prediction. What a healthy loop looks like over time. Now we describe the prediction of a functioning meta loop in simple, everyday terms. If the loop is healthy, then over time you should see three trends. 1. Narrower uncertainties. Error bars shrink. Predictions become sharper. Measurements become more precise. The fog recedes. 2. Fewer ad hoc patches. A healthy field does not grow a jungle of exceptions. A healthy field becomes simpler and deeper over time, because better data reveals that the old complicated rule was an approximation of a simpler, more fundamental grammar. Think of how epicycles were replaced by Kepler's ellipses. The older system patched and patched. The deeper system simplified. 3. Converging independent pipelines. Different groups, using different instruments and different methods, should eventually agree on the same invariants if window licensing is correct. If the field is healthy, disagreement reduces over time because better instruments and better protocols align the picture. So the healthy loop predicts convergent refinement, sharper uncertainties, simpler grammars, and agreement across independent pipelines. 11. The pathology, when the loop breaks. Now we speak about the danger, because this part is about keeping science alive, and you only understand life when you can recognize disease. The pathology is methodological degeneracy, also called method overfitting. This is when a field responds to anomalies mainly by adding patches, extra assumptions, special exceptions, auxiliary hypotheses, without improving predictive power. The rule becomes like a broken machine held together by tape. It still runs, but it is no longer a clean engine. It becomes a Rube Goldberg contraption. Signs of degeneracy include uncertainties stop shrinking. They wobble but do not improve across decades. Patches proliferate. Every anomaly becomes explained by adding a new epicycle, a new hidden variable, a new exception. Independent pipelines do not converge. Different experimental approaches keep disagreeing without resolution, and the field learns to live with contradiction. This is a broken loop. It is a science that looks alive but cannot heal. Now the firewall response is severe, because this is not a small error, this is a systemic disease. First, trigger a pathology alert. Officially flag the domain as degenerating. Second, freeze promotions. Halt certification promotions for new rules in this domain until the loop is repaired. The field cannot keep awarding itself higher trust while it is methodologically sick. Third, reopen model class search. Mandate a fundamental review. Fund radical new instrument concepts and new grammar families. The goal is to shock the loop back into healthy operation. This is important. The firewall does not only punish bad rules. It treats method disease as a real thing. It intervenes at the level of the method itself. A historical cautionary tale. Phlogiston. Now let's give the listener a vivid historical example of degeneracy and repair. Phlogiston. In the 18th century, phlogiston was a candidate grammar for combustion. It was supposed to explain burning and calcination. But testing revealed anomalies. Metals gained weight when burned, which contradicted the theory's expectations. The community often responded with patches. Phlogiston has negative weight. That is exactly what degeneracy looks like. Patching to save the core idea, without improving real predictive power. Then came a methodological upgrade. Lavoisier introduced precise weighing and careful accounting. This was not just a new theory, it was a new instrument discipline. The sentence set became sharper. The old patched grammar could not survive the improved sentences. A deeper grammar emerged: oxidation and conservation of mass. This is the meta loop working through turbulence. Old grammar, anomalies, patches, then instrument upgrade, then grammar replacement. The lesson is not phlogiston people were stupid. The lesson is, without a loop, humans patch. With a loop, reality wins. 13. What is allowed and what is forbidden? Now we make the ethics explicit. What is allowed? You are allowed to have approximations. You are allowed to have incomplete rules. You are allowed to have uncertainty. In fact, every real science begins in uncertainty. But you must be engaged in an active meta loop. You must use improved instruments to retest. You must refine your windowing. You must report uncertainty honestly. What is forbidden? You may not treat a rule as finished or beyond testing. You may not respond to anomalies mainly by adding complex, unmotivated patches instead of seeking better data. You may not ignore major disagreements between experimental pipelines without launching a dedicated investigation. In short, you may not freeze the method. 14. The badge of a living science. In the firewall system, a healthy field earns a badge, dynamically refined. This badge does not mean this field is right forever. It means this field is alive. It is self-correcting. Its uncertainties shrink. Its grammars simplify. Its independent pipelines converge. Its shadow archive is active. Its tools keep improving. A dynamically refined badge is a mark of epistemic maturity. 15. The skill you gain. Audit the loop, not the claim. Now we return to the skill you gain as the listener. You become someone who audits the loop, not the output. When you hear a scientific claim, you ask, what is the current sentence set? How old are the instruments that produced it? What is the rule's lineage? Has it simplified over time or accumulated exceptions? Are uncertainties shrinking historically? Are independent approaches converging or diverging? This skill lets you distinguish a vibrant science from a stagnant one, even if both are loud. because the loudest thing is not always the healthiest thing. 16. The closed meta loop as the ultimate expression of the core axiom. Now we re-say the core axiom again, because part 57 is its engine. Rules do not become real by elegance, consensus, or tradition. They earn a license only by surviving falsification, variation, independence, and scope discipline. The closed meta loop is the engine that makes the survival process continuous, and the firewall action remains consistent. When a rule fails, we do not believe harder. We tighten, downgrade, or retire its license. But now we add something deeper. When the method fails, when the loop shows pathology, we do not just patch the rule. We intervene at the methodological level. We freeze promotions, trigger reviews, and force innovation in how we see. We shock the system back into a state where it can learn. The meta loop, in one simple picture. Let me give you one simple picture you can hold. Imagine you are in a dark room trying to understand the shape of furniture. You have a flashlight. You shine it and you make guesses. Those guesses are grammars. But if your flashlight is weak, your guesses are limited. Now imagine you upgrade the flashlight. You see sharper edges. Your old guess is corrected. Then your sharper guess tells you where your flashlight still fails, where shadows hide detail. So you upgrade again. That is the closed meta loop. Science is not having the final answer. Science is improving the flashlight and correcting the guess again and again. Crystallization. What part 57 formally does in audio language. Now we crystallize part 57 clearly. We have defined the closed meta loop. This firewall mechanism formalizes science as a recursive, self-improving system. Phi sentences lead to candidate grammars. Firewall testing of those grammars produces diagnostics, often from anomalies in the shadow archive, that reveal weaknesses in omega, kappa, and nu measurement. Those diagnostics drive upgrades to instruments and window licensing methods. The upgraded instrument suite produces cleaner, higher-resolution Phi sentences. Those improved sentences refine or replace the grammars. The cycle repeats. The loop demands balanced triunity improvement. Omega, kappa, and nu uncertainties must tighten together. The stability of energy tallies is explained as improved accounting due to reduced measurement leakage and better boundary definition. The firewall acts as the loop auditor. It checks rule lineage for iterative improvement, mandates retesting with upgraded instruments, and evaluates whether a field is alive or stagnating. The prediction for a healthy meta loop is convergent refinement. Uncertainties shrink, ad hoc patches decrease, and independent pipelines converge on the same invariants. The falsification condition is methodological degeneracy. Patching without increased predictive power, stagnant uncertainties, and persistent, irreconcilable disagreements. The license consequence is systemic intervention. A pathological field is flagged, promotions are frozen, and a fundamental methodological review is triggered to restore the loop. With the closed meta loop, we complete the architecture of a learning system. The firewall is not a static filter. It is a governor on an engine of discovery that upgrades its own vision. The forward question: can the firewall itself evolve? And now we end with the final question that points forward. We have built a firewall with mechanisms to test rules, archive failures, validate across civilizations, and self-improve through a meta loop. But what if we encounter a failure mode so deep that the loop itself cannot correct it? Salam, and peace be upon you.